Hello everyone, and welcome back to another episode of Simply Science. Okay guys, the first thing we are going to do today is write our name and date on the top of the lab sheet that we've already printed and highlight our I can statement. So our question of the day is, which of the items basically will conduct electricity and which won't? And are there any that you think will only let some electricity through and not all of it? So right now, I would like you to hypothesize, and we know that a hypothesis always starts with, I think. So take this time now to hypothesize. Great, so now you have made your hypothesis. Let's discuss what we're actually going to do in the lesson. So I've constructed a simple circuit, and if you have the proper materials at home, you could do this along with me. I've constructed a simple circuit and I've left a gap like I showed you in yesterday's video, so that I have a place to put in all of the test items. Now basically, when I put the test item into the circuit, it's going to complete the circuit. Now if it's a conductor, the light bulb will go on. And if it's an insulator, the light bulb will stay off. And just like yesterday's lesson, just review your knowledge of, a conductor allows electricity through, an insulator does not allow electricity to get through. Okay everyone, I have found the materials I need. I've got a popsicle stick, some pencil graphite, silver paper clip, Durham coin, binder clip, eraser, and I couldn't find a rubber band, so we're going to use an elastic band. Okay, so I've wired my simple circuit. Like I said, let's start connecting our materials. So let's start with a popsicle stick. So you take your alligator clip, clip on, other alligator clip, clip on. The light bulb does not go on. Okay, so what does that mean? The popsicle stick is not conducting electricity. Binder clip. The light bulb is going on, so the binder clip is conducting electricity. All right, let's move on to the eraser. Alligator clips. The light bulb stays off. The eraser is not conducting electricity. Rubber/elastic band. The light bulb stays off. Silver paper clip. The light bulb goes on. It is conducting electricity. Durham coin. All right, the light bulb went on. It is conducting electricity. Next up, we have pencil graphite. So all I've done is basically take all the wood off the pencil and just expose some of that graphite. It's commonly known as pencil lead, but that's because in pencils they used to use lead, and then they discovered that lead is actually toxic, so they replaced it with a mineral called graphite. Okay, so I'm going to connect. If I connect it to the wood, it's going to be like a popsicle stick, right? It's not going to conduct any electricity. So let's try connecting it just to the lead there, and on the other side as well. Interesting. The light bulb has gone on, but it's not as bright as the other ones. It seems to be letting some electricity through, but not all of it. We'll come back to that. Okay, I've also brought some fun mystery items. So let's try plastic BB-8 straw. The light bulb, of course, did not go on. Plastic haunted house cookie cutter. Let's try a whisk. The light bulb has gone on. Excellent. Let's try it at the bottom of the whisk. Let's see if that actually works. Okay. So it doesn't actually work, which leads me to believe that this handle is actually hollow. So the electricity can't connect all the way to the bottom because there's actually not solid metal inside of this. That's my hypothesis anyway. Okay. Let's try a plastic fork. Interesting, no light. Let's try piece of paper. Any predictions? Hopefully you correctly predicted. It's not conducting electricity, the light bulb is not on. All right, let's try my pen, but let's try this metal part here. There you go, it is conducting electricity. But what will happen if I attach near the bottom of the pen? Nothing's happening. But that's because it goes from metal into plastic. Let's try this thing, which Mr. Chris says is a spatula, but I thought spatula spoon? Anyway, not sure the official title, but let's try it anyway. As you know, Miss Rachel's not much of a chef and more of a scientist. Aha! That light bulb went on right away. That is conducting electricity. Let's try a nail. A brass tack. Wow. Very quick to conduct electricity. Let's try a screw. Alrighty. Let's try a soda water can. Wicked. All right, great work everyone. So now we're on to the conclusion section of the lesson. So this first part of your sheet is actually just a table that says conductors, insulators, and resistors. And I would like you to sort the test items into those boxes. Now I'll give you a hint, only one of the test items we used is a resistor. The rest fit nicely into the conductors and insulators category. And I'll just remind you guys that in order for a material to go into the conductors column, it has to allow electricity to go through, which means the light bulb went on, and the opposite for the insulators, so the light bulb did not go on, okay? So that's how you can categorize your items. Okay, so now that we've sorted all of our test items into our respective categories, we would like to move on to the questions on our sheet. Okay guys, question number 1. So what did all of our conductors have in common? What was similar about all our conductors? Hopefully by now you've concluded, or even during the demonstrations, you realized that all our conductors were actually made of metal. So the great thing about metal is it is an excellent conductor, and most metals are actually conductors of electricity. So if you want to try this with other metals at your home, you'll notice that almost all of them will be excellent conductors of electricity. Okay, question number 2. What is similar about all of our insulators? So it's kind of what they have in common, but also the answer is just kind of how they're different from metal. Basically, insulators are usually made out of wood, plastic, rubber. That's what they have in common. They're basically not made of metal. Okay, question number 3. Were there any materials that only allowed some electricity through? So if you can take a moment and think back to when I was demonstrating on our items, were there any items where the light bulb kind of acted differently, where the light bulb was a little dimmer? Okay, hopefully by now that you've pinged in and thought, oh yeah, actually the pencil lead, the light bulb was actually a lot dimmer, which Miss Rachel mentioned. So pencil graphite, not lead, sorry, is a resistor because a resistor only lets some electricity through. All the other substances, the conductors, let electricity through fully, instantly, and the light bulb was bright. Whereas the pencil lead actually only let some through, and the light bulb wasn't as bright because the pencil lead's actually keeping some of that electricity from going through the circuit. Okay, number 4, which kind of we just answered in number 3, but what is a resistor? So a resistor is basically a substance that lets some electricity through, but not all. And a good example of a resistor is pencil graphite. So in conclusion, guys, today we have learned the difference between a conductor and an insulator. We've tested various items to see which conduct electricity and which don't. We have also learned what a resistor is and how a resistor is something that only allows some electricity to go through and not all of it. Okay, so great work today. Review these concepts and please message me, Mr. Matt, or Miss Mavish on Edmodo if you have any questions. And guys, please don't forget to complete any outstanding assignments that you might have on Edmodo. Do the daily attendance question and message me if you have any problems. Great work today, everyone, and we will see you tomorrow on another episode of Simply Science.